All right, welcome. This is the surface area and lateral area formulas for a one-base figure right here. And we're going to find a formula for this today, and then we're going to use the formula and see how it applies to problems. So a quick rehash. Surface area is everything. This face, this face, this face, this face, this face. In fact, you can handle surface area by just finding the sum of all of the faces. You'd have to find this area, this area, this area, this area, this area, and then you add them all up. You can do that for any figure. You can find all the faces and you can add them up, and that'd be the surface area. But anyway, surface area is the whole thing. You add up all the faces. And lateral area is everything but that base it's sitting on. So it'd just be these triangular faces right there. So we have really two ideas. Is it something we can pick up and move around? And if it is, we could find the surface area of the whole thing. Is it something that is, boom, sitting there and I can't pick it up and I just want to cover these faces? Well, that'd be the lateral area. So for this, lateral area is going to include everything but the base. Okay? So surface area of this thing. Well, the essence of it is if I could find the area of the base and add to it the area of these four triangles, I would have the surface area of the whole thing. But these four triangles are also called lateral area, and they have a different formula altogether. And that formula is simply this. If I found the area of this triangle here, but I thought about the whole perimeter of this whole thing, so if I take the perimeter of that, and then the height of this triangle right here, and then triangles usually have a half in it, so it's like I have a half this thing here, and then the perimeter. That's really going to be the lateral area. It's called 1/2 PL is lateral area, and I take the perimeter of the base and I multiply it by this L value, and it has a special name. It's called the slant height. If I multiply it by that L value, what I'll get is I'll get the lateral area of this thing, and then for the surface area, just add in the base. Okay? So I'm going to go back to a page that we had started here. There's really two ideas for a one-base figure. So first of all is lateral area. And again, it's those triangular faces. And that lateral area has a formula. It's 1/2 PL. And the P value here is called the perimeter. Of the base. And the L is the slant height. L is the slant height, P is perimeter of the base. That will handle the lateral area of the figure. For the surface area, I take that same formula, 1/2 PL, and I add in just that bottom base. I add in a big B. So this perimeter of the base is here, and the slant height is still here. You can see those two formulas are basically the same, except surface area adds in that bottom base. Okay? All right. If you want to search a video on where those formulas came from, I usually do an in-class presentation on how you unfold this and why it's 1/2 PL. I don't think it's really applicable for a video setting like this to do that, but you might be able to find some really cool demonstrations on where those formulas come from. We're going to focus on using them and how to use them in a problem. All right, so here I have a perimeter, or a square pyramid, and I'm going to find both the lateral area and the surface area. Okay? And again, very, very formula-based. I mean, this is a problem that you're going to just write down the formula every time. So this is 1/2 PL, and the surface area is 1/2 PL plus big B. Okay? So 1/2. P stands for perimeter of the base. Perimeter of the base. So I'm going to take the base here to a square pyramid, and I'm going to find around the outside of the base. So 12, 12, 12, 12. P stands for perimeter of the base. So 12 plus 12 plus 12 plus 12 is 48. Okay? 12 plus 12 plus 12 plus 12 is 48. 4 times. Times the slant height. Now, the slant height is this. If you have one triangular face of the pyramid, Or it even works for this cone here. You have a cone that I don't really have a triangular face, but I still, in essence, I have this same distance down this outside edge here, okay? That distance is called the slant height. Now, it is not an edge. It is definitely not the same height that we used in volume. In volume, we went finger to finger. We had to have a perpendicular height. This slant height is what you get if you take a marker here and you draw it right down the outside of it. Can't even hardly see that, but it's there. That down the outside right there, right angle. The slant height is basically, in essence, it's the height of one triangle. So if you could find the height of one triangle, I gotta do a better job than that. Here we go. Here we go. That right there, it's a funky cursive L. That right there is called the slant height. It's down the outside. So if I want to use that slant height, all I got to do is take it. Ooh, it's 18 right there. That's in the right spot. I should have had a right angle in there. 18. So here we go. 1/2 times 48 times 18. And I got 432. Okay, that's the LA. And the cool part is, whenever I get this, plug it right in over here for the slant surface area, 432. Half the surface area formula is already rolled up into here. Plus the base, and big B stands for area of the base. Area of the base is 12 times 12, or 144. So I take 432 plus 144, and I get 576. 576, does it give me any? Okay, so units squared. Your surface area should always be bigger than your lateral area. So this number here would be all of those triangular faces. This number here would be all of the triangular faces plus the bottom base. All right, next one. Surface area of a one base figure, 1/2 PL. That's lateral area. Surface area, 1/2 PL plus big B, area of the base. So I take 1/2. P stands for perimeter of the base. Perimeter of the base. It's not 16. Perimeter of the base is around the outside. Well, that's circumference of a circle. So in for the P, I have to use the circumference of a circle formula, which is 2 pi r times L. And the trick to doing this, the number one trick to doing this, is after you write that down, you substitute in the formula in for P. Just like in the last section, I substituted in for B, I substituted in pi r squared when I did volume of these things. Well, P, I'm going to substitute in 2 pi r, because that's the perimeter of the base. Now I'm going to go 1/2, 2, pi, radius, 8, slant height, 20. Half of 2, whap, gone. 8 times 20 is 160. This answer is 160 pi square units. You could do math like that pretty easy on some of these. 160 pi is 502.7. 502.7 square units. 160 pi goes right here. 160 pi plus area of the base. Well, again, the base is a circle. Area of the base is pi r squared. So I take 160 pi plus pi, and my radius is going to be 8 squared, or 64 pi. And the answer for the whole surface area is 160 pi plus 64 pi. And I got 703.7. Again, square units. I should do it exactly. 160 plus 64 is 224. 224 pi square units. So the top answer in each one of those is actually what the ACT would read. And honestly, surface area of a cone is an extremely common problem that they put on the ACT. And they're going to write the answer like that. They're not going to put it 703.7. They're going to ask you to run through the formula. And then a lot of times they give you the formula for this. They won't even make you memorize it. But it's 224 pi. And that's the type of answer that'll appear on in the blanks of the ACT. All right, fun one now. Octagonal pyramid. And I give you the slant height here. Okay? And we got to find the area of the base and do the whole thing. So here we go. Lateral area is equal to surface area is equal to lateral area 1/2 PL, surface area 1/2 PL plus the area of the base. So 1/2. The perimeter, well, 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon. The perimeter is 10 times 8 or 80. And the slant height is 32. And that's a pretty easy problem to find the lateral area. Times 32. I got 1280 for this. 1280 square units. And again, here is that picture. I'm actually finding the surface area of something like this. Okay, what I just found was I found all these triangular faces right there with that formula. It's around the outside. It'd be a pyramid that was sitting here, and maybe I couldn't pick it up and manipulate it. It's just, bam, it's there, and there's not much I can't, it's too big. Okay, got 1280 square units, and that goes here, 1280 square units. And now I need to go in and I need to find the area of that base, because all of a sudden, boom, I can pick it up and I need to be able to manipulate it and find that part. All right, so here we go. Let's find the big B calculations. I'm going to put it down here. So I'm going to draw part of it. I'm going to find the area of the triangle, and then I'm going to multiply it by 8 triangles. I got 10 here. I'll find that angle in there by n minus 2 times 180 over n. 180 divided by 8. I did that formula. I did 8 minus 2 times 180 divided by 8. And that whole angle is 135. And that little sliver of an angle, divide that by 2. 67.5 right in here. 67.5. And I'll dot it in the height. And I'm doing that whole trig problem now where I'm going to find the area of the base. Okay, so 67.5. I got a little 5, a little baby 5 right down in there, and I got to find the height. Well, let's see. Opposite, adjacent. Opposite, adjacent. Opposite adjacent is tangent. So I'm going to do the tangent of 67.5. Tangent of 67.5 equals opposite h over adjacent 5. That's not too bad. The tangent of 67.5 times 5. I got 12.07 for the height. My height is 12.07. So let's run through a calculation. I want the area of one triangle. Area of one triangle, which is 1/2 the base, 10. 10. 1/2 the base, 10. Times the height, 12.07. That's the area of one of these single triangles. One of these single triangles. Well, I have 8 triangles. I'm going to put down there times 8. I'm gonna run through that part just right there. So I'm going to take 1/2 times 10 times that 12.07 number times 8. And I got 482.84. So I take 1280 plus 482.84. Got a little bit crunchy there. It's okay. That plus 1280. And I got 1762.84 for the surface area. 1762.84. And that would be square units. So we have the lateral area and the surface area right there. Okay, that takes me to the end of the problems where I actually gave you the right slant height. And Here's a little bit harder problem. It's the same concepts, 1/2 PL, find the lateral area, surface area, 1/2 PL plus the area of the base. But they're not always going to give you the slant height, and you have to be smart enough to go in and find it. It doesn't usually take a ton of math, but it is a visual. It is a visual to go in and find the right piece. They don't want this side. They don't want finger to finger the height of the object. They want that slant height going straight down from the point, straight down perpendicular to the side. If you're looking at it, it's basically the height of one of those triangles. That's what they want. Okay? So here we go. Lateral area. 1/2 PL. Surface area. 1/2 PL plus big B. Lateral area. 1/2. The P. P stands for perimeter of the base. It's a circle. 2 pi r is the perimeter. That perimeter right there is right there. That P is 2 pi r. Slant height, ugh. I don't have it. I'm going to put an L there. Let's plug in some numbers. 1/2, 2 pi. My radius is going to be 5. 5. And my slant height, I don't know, but I do know this is 5 right there. Okay? So now my slant height, there's my L. Now that I've drawn on it, I hope you see it. Yep, you got it. Good job. It's a right triangle problem. It's Pythagorean theorem. 18 squared plus 5 squared equals L squared. We'll handle that. 18 squared plus 5 squared. And I got 349. My L squared is 349, and I will square root 349. I don't think that's even. Second, and you could actually just leave it this square root of 349 and carry out your exact answer, but I think for the purposes of this video, we'll go ahead and take it down to a decimal. 18.68. 18.68 is the slant height. That L value right there is 18.68, and I can plug that in here, 18.68. And now I can perform my calculation. This isn't too hard. 1/2 times 2 wipes each other out, so all I really have to do is take pi times 5 times that 18.68, and I got 293.45. 293.45, and that would be square units, and that goes here, 293.45. Plus, well, I need area of the base. Big B stands for area of the base. P stands for perimeter of the base. Big B stands for area of the base. 293.45 plus pi r squared. Pi, well, my radius is 5 pi squared, 293.45. I'm going to crank that through my calculator. 293.45 plus pi 5 squared, and I got 371.99. 371.99, and that would be square units. Square units. Got the lateral area, got the surface area. Oh, just a couple more. All right, here's another one. And I did not give you the slant height. I gave you the height. Now, if I was doing volume, I would use that 16. But I'm not doing volume. I'm doing surface area and lateral area. So here we go. Lateral area is equal to, oh geez, 1/2 PL. And surface area is equal to 1/2 PL plus the area of the base. So I take 1/2 the perimeter of the base, 20, 40, 60, 80. That's easy. I could just count that. 20 times 4, 20, 40, 60, 80. P stands for perimeter of the base. P stands for perimeter of the base. Perimeter of the base. 20, 40, 60, 80. L stands for slant height. I don't have it. Dot it in. What do you know? That's 10. I got another right triangle problem. Most of the time, I said it would require just a little bit of work. Most of the time, it's a right triangle problem to find the slant height. Okay, I'll put an L there. That's 10. There's my right angle. 10 squared plus 16 squared equals L squared. 10 squared plus 16 squared equals 356. L squared is 356, and this is the square root of 356. And I square root it. Oops, not the edge. That's slant height. And the square root of 356, 18.87. 18.87. So I take 1/2 the perimeter times the slant height, which is root 356. Honestly, the ACT would take half of 80 and write it 4 radical 356. That's exactly what it would. That weird answer is what it would be like on that test. But I'm gonna go ahead and decimalize it. Times 40. 754.72. 754.72. And that would be square units. So this is 754.72 plus, well, now I need the area of the base, 20 and 20. 20 times 20 is 400. Plus 400. B stands for area of the base. Area of the base, so I went and found the area of the base plus 400. And I got 1154.71. Or did I round it right? 72. 72 squared units. Surface area, lateral area. All right, last problem here. Last problem, hexagonal one. Okay, or a pentagonal one. So let's find the lateral area first. Lateral area is 1/2 PL, 1/2 the perimeter of the base, 8 times 5. Okay, there's 5 sides of 8, so the perimeter of the base is 40. The slant height, I don't know. This 30 is to this edge. I don't want the edge. I want this slanty height right here. There's the right angle right there, and there's my L value. This time that L value is a leg. Still a Pythagorean theorem problem, but here I'm going to, instead of use 8, I'm going to use a 4 down there, half the 8, and I'm going to go 4 squared plus L squared equals 30 squared. That should do it. 4 squared plus L squared equals 30 squared, which means L squared will equal, I'm just going to kind of do this like the following. I got 30 squared. I'm going to subtract that 4 squared over the other side. And I can type that in my calculator like that. I can go 30 squared minus 4 squared. And I get 884 for L squared. 884, and then I can square root that on my calculator. You should be following along with this. I know it's easy to watch me do it, but I'm hoping you're maybe pausing the video at times and trying to do this and following along. I got 29.7 for my L value. 29.7, and that's what goes in right here, 29.7. So half of 40 is 20. I'll take that 29.7 times 20, and I got 594.64. 594.64, and that would be square units. Units squared. Okay? Surface area is equal to 1/2 PL plus big B, 1/2 oops, I don't even need to do that again. I'm going to back that up a little bit. Plus big B, which is I almost did it again. 594.64. 594.64. That's the lateral area. That's the 1/2 PL, 1/2 PL. If I can find the area of the base, I'm done. So I got my triangle. I challenge you right now. Press pause. You go and find the area of that base. Another polygon problem where a regular polygon where we have to go in and find it. So this is 8. Go in and find the angle, find it all. Press pause right now and do it. Okay, here we go. I got n minus 2 times 180 over n to find that whole angle. So I take 5 minus 2 times 180 divided by 5. And I get 108. I divide that by 2. And the angle that I'm going to use, the angle in question here is 54 degrees. 54 degrees right there. I'm going to dot in my height. There's my h. This little part is 4. And just like before, opposite adjacent, it's a tangent problem. So I'm going to do the tangent of 54 equals opposite h over adjacent 4. I'll take the tangent of 54, multiply it by 4. I get 5.05 or 5.5 basically. My height is 5.5. And I think I can go here and I can find the area of this thing. Area of the base is area of one triangle. And I'm going to have 5 triangles. One triangle, 5 triangles. One triangle is 1/2 the base, which is 8. The height, which is 5.5. And 5 triangles. So that times 5 times that, I got 110.11 for the area of the base. 110.11, so plus 110.11, and I'm going to add those two numbers together, that plus 594.64, and I got 705.1, 705.1, and that would be square units. And that's the end of your one base surface area. And again, as you go through these, decide, is it asking you for the area of the whole thing? Is it asking you for just the triangular faces without the base? Assume that if it doesn't say otherwise and it asks for surface area, assume that it's an object you can pick up and move around. It's not something that just sits there. If it just sits there, I will tell you, hey, it's one you can't pick up. Might even say, hey, find the lateral area, depending on the problem and depending on the problem set. So have a great day. Good luck.